test. I don't know. See what it says. Say apply. Yes, I want to overwrite because I already created this. So so now it sends it out to Nastran. Nastran's crunching away on it, and I don't know why it's crunching so hard, but then it's done. So now, once it's done doing that, you have to remember to come up here and pick XDB and select your results file. And I didn't change the name on mine, so we're going to do that one. Say OK. And then apply. And now we can go to results. And we know it's working because we've got these, results in here. Okay, so we're doing a quick plot. And we can do displacements, the magnitude, translation, and hit apply. Ooh, we got pretty pictures. Okay, so now the question is, so I can, it's kind of small.
How do you just do that? I just go on.
If you hold down the control in the middle mouse button, if you push the roller, if you push down while holding control,
oh, okay.
And if you do shift in the middle mouse, you can pan around.
Okay. Oh, sweet.
Okay. Okay. So it's saying that that's my max displacement. Okay, where's our, what we calculated? Okay, do we believe anything on the screen?
No, never.
There you go, gold star for Brad. No, never. It's all lies. Okay. So let's see, we said we had a displacement of...
What if like the writing is like off the screen?
That part I don't know. I'm still figuring it out. Well, I'm going to turn my labels off because I don't want to look at those anymore. So turn the labels off. Oh, I got to do it. There we go. Okay. Now if I hit apply. Okay. So it says my max displacement is 1.24 times 10 to the minus 2 at node 2. But that's not what we figured out, is it?
Does it say what direction that's in then?
Well, excellent point. So yes, you see here we have this, just the quantity is labeled at magnitude. So if we change it to x component and reapply, there we go. Does that look like a number that we came up with? Is that number in your notes? Yes, it is.
Oh, 438.
Because our displacement at U2 was minus 0.000438. So that's 4.38 times 10 to the minus 4. So yes, we did have that. And then if we go to the Y, say apply, 1.24 times 10 to the minus 2, that's what we got. So that works. Okay, so that was our displacement. So now if we pick stress, what do we want to pick for stress? We have lots of choices. Well, we'll just take von Misses to start out with. Hit apply. Okay, so what do we have? 6.12 times 10 to the third. That's not any number we got, right? Well, it's close to one of them, I guess. It's close to the 1 in 3.
6.19.
But the reality is what we really want to do for this. Oops, that's not where I want to go. Desktop, in. Okay, so remember I talked about that F06 file. Oops, Notepad. So F06. Okay, so we go clear down to the bottom. So they have displacements, some of this other stuff. So here, stresses in rod elements. So node 1, axial stress, node 3, node 2. So that's where we would pick, that's the best place to pick up those numbers.
218.
And they also talked about the forces. Let's see, we got displacement. So there's our minus in the X, plus in the Y. So we'll be coming back to this F06 file and looking at it for a lot of our information. But so hopefully you're less likely to believe the siren songs of the pretty pictures. But yeah, for the simple stuff, this is real convenient. And even for some of the complicated stuff, it's I was talking to an industry advisor that works at Boeing, and he says they interrogate this file all the time. They have special macros for pulling data out of it. And they look at the pretty pictures, but they spend more time looking at the F06 file. So anyway. Okay, so it worked, and what we did worked. Questions? That makes sense? I mean, it's kind of exciting, right?
If you animated it, it's really exciting. Because
Oh, yeah, you could. Oh, yeah.
Just push the animate at the bottom and
And then hit apply. That'll do it.
So will our SolidWorks files go directly into this program?
Yes. Well, you have to make them parasolids or X underscore B's.
It's
Or
just a matter of how you save the file then?
yeah, you just have to export it
Right.
in a format that Patran will pick up.
Okay.
Because yeah, that's what I did for. So we'll save this. I'll close it. Let's see, open. So this one. So yeah, that was just an imported file, and then let's see. You're gonna go to. Well, you got to do loads and boundary conditions for meshing. Or wait a sec. I'm missing something. Oh, here we go. So on properties, you know, you can do your isotropic properties, but instead of the 1D stuff that we're doing right now, you're just going to go to 3D properties.
So then you won't have to pick where your nodes and everything are then, right?
No, this will do it for you.
Okay.
If you pick this, well, yeah, anyway. So no, and you won't.
Okay.
And then when you're meshing, you'll just select this, and it does its thing.
Okay.
And analysis, you run it, and results, and away you go. Let's see, I should have an F06 file for that. So if we go down to the bottom. Okay, so stresses in our, so these are tetrahedron elements, right? You remember what that looks like. And these are the stresses. So it's a little harder to look at as far as knowing exactly where and what you are dealing with. And I haven't tried to sort that out on this yet, but anyway, you can see the data here. And there's lots of it. Well, actually, there's probably one of those for each. Yeah, I don't know how you would. You'd have to have a macro or something to deal with all this to get. The other thing that I want us to do, particularly on, well, this one was too simplistic. Well, and I meant to have it ready and didn't. Let's see, so where's my F06 file here? So we're going to take this data down here, our stresses or our displacements, and we're going to drop that into Excel and make some charts and graphs. Well, graphs to give us a visual of that information. So that'll be you guys' pretty pictures. And I'll have that ready for next time. So, okay. So everybody's good to go?
Yep.